So hello everyone, welcome to OneClass Services channel. My name is Devansh Purohit, and today we'll see some popular physics question. Now these questions are going to be at, let's say, high school level, and it can be at university level, but mostly it is going to be at high school level. And so a little background of myself. So I am in the final year of my graduation in aerospace engineering, and if you need any one-to-one live sessions or if you need any tutoring help, they can check the links in the description below. And So without wasting your time, I'll just start with the stream. Yeah. Mm, So that this is from my last stream, so I'll just add a page here. Yeah. Okay. So we'll start with question number one. So this is, I'll just start with red pen. So it is saying that two plane mirrors are separated by 120 degrees as the drawing illustrates. So we cannot see the drawing obviously. Now if a ray strikes a mirror M1 at an angle of 56 degrees, that means angle of incidence is 56 degrees here. Uh, at what angle of incident that does it leave the mirror? They don't have spaces here. Like it is very hard to read without spaces. So I'll try to make this, and let's say this is the other mirror. Let's say this is M1 mirror, this is M2, and let's say this is a mirror, so it will reflect everything. And now the angle here is 120, and let's say the ray is striking at this point, the first ray. So, and it is making an angle of 56 degrees. So what we do is that we first make a normal here. I'll just make this normal with blue color. So this angle is going to be 90 degree, and the ray, I'll just make the ray with the black color. So the ray is coming from here, and it is making, yeah, finally straight line. So it is making 56 degrees here, and like there is a property of reflection. So basically in the case of mirrors, angle of incidence is always equal to angle of reflection. So when this ray is reflected back, let's say like this, so it will make an angle of 56 degrees. So let's say this point as A, and let's say this is B, and this is um, um, let's say this as normal N1. um, I'll write this with red. So this is normal N1. So my my angle BAN1 is going to be, let's say just for now, let's say this point is C, will be equal to angle N1 AC, and this will be 56 degree because the law of reflection, you can say. Now, so we have got this angle. Now what we'll do is that we'll just try and we'll extend this such that it meets the mirror M2, and it should be a straight line. So I'm just drawing a dotted line here. Mm, Um, yeah. So again, and when this ray is striking this mirror, so I will draw a normal which will be perpendicular to this. I'll just use the angles. Now we are going to just play with this. So here we can clearly see that this is the normal to this surface. So N1 is the normal to M1 surface. So this whole angle is going to be 90 degree, and this angle is 56. So this angle will be 90 minus 56. So it will be 90 minus 56. It will be 34 degree. And we can clearly see that this is a triangle, and sum of the interior angles of triangle is 180. Sum of interior angles of triangle is 180 degree. So we can find this angle. So this will be 120 plus 34 whole subtracted from 180, and this will be 120 plus 34, 180 minus this will be 26. So this angle is going to be 26 degrees, and again this whole complete angle is 90 degrees, so I can find this one. So this one will be 90 minus 26. 90 minus 26, this is going to be 64 degrees. And again, angle of like law of reflection, so angle of incidence will be equal to angle of reflection. So let's say this is 64 like this. In the question, okay, so first thing is that we need to calculate it I2. So I2 is going to be 64 4 degree, and it is asking that does it leave the mirror M2. So yeah, it is leaving the mirror M2. Let's just cross check with the solution here. So yeah, 64 degree, and by fact one that theta equal to 64 degree. Okay, so the solution given here was correct, so I'll just say correct solution. Good work.